In the previous two examples we took, or previous two videos, excuse me, we took a look at the idea of symmetry and where does symmetry exist for functions as well as relations. And we never really looked at the graphs though until we plugged them into our graphing calculator or to our grapher. And so that's what we're going to take a look at this time is what if we went backwards and we had the graph? So in these examples, what we want to do is we want to determine, first of all, if it's a function, all right? So determine if it's a function or not a function. And then if it is a function, determine if it's even, odd, okay, or if it's neither even or odd. And if it's not a function, describe any symmetry that might exist. All right, so first things first, okay, is it a function? And you might remember to determine if a relation is a function from the graph, we use the vertical line test. And so I draw my vertical lines and notice that it intersects at exactly 1 point anytime I draw a vertical line, which means it does pass that test, which means that yes, it is a function. All right, so because it passes the vertical line test, we say yes. All right. Now, secondly, so that's the first part of this, right? Secondly, we want to determine if there's any symmetry, okay, to determine if it's an even function or an odd function. So, is it even or odd? So remember, even functions, okay, means that whenever we have f at negative x, that equals f at x, all right? So let's take a look at these points right here. And it looks like that it could be even because f at -2 is equal to f at 2, which is equal to 0. But let's take a look here. Okay, so we notice that right here, these 2 points are equidistant. And it looks like that if I pick any point, like down here, it looks like these points are equidistant. Okay, so that means that it looks like it's symmetric about the y-axis, which means that there's going to be symmetry about the y-axis, which means it's an even function. Okay, so it's even, and that means it's symmetric about y-axis. And then finally, we look for odd symmetry because we saw that sometimes there are these relations that have symmetry both about the origin as well as an axis. But if I look at this point right here, there should be a point somewhere down here that's about the same, and clearly there's not, okay? So if we look at like the line y equals x, there should be the same point, and it's not. So we'd say that there's not going to be odd symmetry. And we remember that for odd symmetry, f at negative x equals negative f at x. Okay, so that doesn't exist on this graph. So to summarize this, it is a function, but also it exhibits even symmetry. Next one we have, right, this function right here. And I say it's a function because, first of all, if I try the vertical line test, it looks like it's going to pass. I know some of my vertical lines are a little bit skewed. Apologies. So let's try that again. So yeah, that one's good. That one's good. And so we would say function. And yes, it is because it passes the vertical line test. All right, so that's easy enough. So that means all we need to do is we need to determine if it's an even function or an odd function. And so is it even? All right, well, if we have this point 1, 2, that means there should be another point, negative 1, 2. All right, but clearly, if I look at this, there's not another point right here. Okay, so certainly can't be even. All right, but is it odd? And remember, odd means that if I have f at 1 is equal to 2, that means that f at -1 should be equal to -2. And it looks like right here that we do have that point, okay? So we could say yes, at least for 1 point. And of course, we want to check to see if other points exist. And so it looks like this point is going to be about the same reflexively as this point. And remember, we have to make sure that the point is reflected in the line, or if we were to trace it through the origin, it will be equidistant from the origin on that function, which it is. All right, so it is a function and it is an odd function from the graph. All right, or at least it seems to be. Now we can't say that with any certainty, but at least it looks like it is. Okay, and that's what we're trying to do. All right, it's possible symmetry. All right. So another example right here. All right, now we draw a vertical line, and clearly it's not a function. Okay, so function, no, not this time. It fails the vertical line test, but that doesn't mean it doesn't have symmetry. In fact, it looks like it has lots of symmetry. And so we look and see that if we plug in 0, so we have f at 0 is 2, but then also f at 0 is -2. All right. And that means that there is going to be some symmetry about the x-axis. Okay, because remember, if we plug in y values, it should get the same thing. Okay, so when we plug in -y, it should get us back the same. All right, and clearly it's equidistant from here to here. Okay, so for our symmetry, so far it looks like that we have symmetry in the x-axis. Right? For the y-axis, it looks like that there's symmetry there as well. Because if we look at the graph, there's this point, which is f at 2 is 0, but also f at -2 is 0. And that follows the exact rule that if we plug in a negative x, we get the same value for y. So it certainly looks like that there's symmetry about the y-axis as well. But what about the origin? All right, so let's check that. And so if I look at the points that are catty corners, so I have a point here, like on this rounded edge, and we have a point here, and we're looking, and they look like that they're equidistant from the origin. And then if we went over here, and we went over here, same thing happens, right? And of course, that's not the only points, okay? There's a lot of other points that look like they're reflected in the origin. So this one looks like that we're going to have symmetry for the relation, but not a function, about 3 places. It looks like that we're going to have x-axis, y-axis, and the origin. Now, finally, we take a look at this function or this graph, and we just use a vertical line test. And yeah, it's going to be a function. So function, yes. But let's check the symmetry, or let's check for symmetry. And remember, we just want to see if it's even or odd. So is it even? All right, so let's take a look at this point right here. Okay, so we have this point -2 looks like 1. All right, so this is the point -2, 1. So if it's even, there should be another point 2 comma 1. All right, but there's clearly not. So it's certainly not even. Okay, and let's see if it's going to be reflected about the origin. Well, remember with the origin, that means that if there's a point here, there should be one that's equidistant from the origin, but clearly it's not even centered about the origin. Okay, so it's not symmetric about the origin, which means that it's not odd. Okay, so it is a function, but it exhibits neither symmetry. Okay, and that's okay. We don't have to have functions exhibiting symmetry all the time. In fact, there's many more functions that do not exhibit symmetry than there are that do. Okay? So that's just some examples of being able to look at the graphs and being able to determine if a graph represents a function or relation, and then to identify the symmetry of those functions or relations. All right, so in the next video, we're going to start taking a look at increasing and decreasing in constants intervals, and then we're also going to take a look at maxima and minima of our graphs.